Hello everyone, welcome to my YouTube channel. My name is Amrita E and I'm currently pursuing engineering in Sri Venkateswara College of Engineering. Today I am here to talk about a comparison of Verilog and VHDL for digital system design. A comparison of Verilog and VHDL for digital design. This presentation will explore the strengths and weaknesses of Verilog and VHDL, two popular hardware description languages used in digital system design. Introduction to Hardware Description Languages. Definition: HDLs are specialized programming languages used to describe the behavior of digital circuits. They allow engineers to model and simulate electronic systems before building them. Purpose: HDLs provide a way to express the functionality and structure of a digital system in a way that is easy for humans to understand and for computers to interrupt. Verilog syntax features and use cases. Verilog is a hardware description language used for designing and modeling digital systems primarily for application in FPGA, that is programmable gate arrays, ASIC, application specific integrated circuits, and other hardware systems. It allows engineers to describe both the behavior and structure of electronic circuits. Verilog syntax. Verilog syntax is similar to the C programming language, making it somewhat familiar to engineers with software development experience. However, its primary use is to describe hardware behavior and structure. Basic structure of Verilog code. Verilog code is structured into several key elements. Modules. A module is the fundamental unit in Verilog, encapsulating a design or sub design. Every Verilog design is defined within a module. Ports. Ports define the interface of the module with the outside world. Example: inputs, outputs, bidirectional signals. Statements. Verilog uses a variety of procedural and continuous assignments to describe how signals behave. Key features of Verilog. Verilog has several important features that make it suitable for digital design. Modeling capabilities. Behavioral modeling describes what the circuit does, not how it does it. This is done using always or initial blocks. Structural modeling describes the physical structure of the design, often using gates and modules. Data flow modeling uses continuous assignments to describe how data propagates through the system. Types of descriptions in Verilog. Combinational logic. The logic where outputs depend only on the current values of inputs. Example: assign out is equals to in1 and in2. Sequential logic. The logic where outputs depend on past input values, typically using flip flops and registers. Finite statement machines. Verilog is used to describe state machines that are crucial in digital systems for controlling the flow of data and operations. Example: a simple FSM implementation might include states like IDLE, start, running, etc. Time and delays. Verilog provides simulation specific constructs for timing and delays, which help simulate how circuits respond over time. VHDL syntax features and use cases. Syntax: VHDL is an HDL with a syntax that is based on ADA and Pascal, making it more structured than Verilog. Features: VHDL provides features like strong typing, abstract data types, and object oriented programming. Use cases: VHDL is commonly used in aerospace, defense, and industrial automation applications. Strengths of Verilog: simplicity and consciousness. Verilog's C-like syntax makes it easier to learn for programmers who are familiar with C-based languages. Verilog is designed to be easy to learn and use, particularly for engineers with a background in software or digital electronics. Its syntax and structures are relatively straightforward, making it accessible for quick adoption in a variety of design scenarios. Familiarity for programmers. Verilog syntax is similar to C, a widely known programming language. For engineers who are familiar with C or similar languages, transitioning to Verilog for hardware design is less difficult. For example, the use of if else, for, and while in Verilog resembles typical programming constructs in C. This similarity makes Verilog code easy to read and understand for those with a software development background. Consciousness in Verilog. Verilog allows designers to write less code while achieving the same functionality. This consciousness is particularly valuable when designing large systems or when performing simulation tasks where quick changes and iterations are necessary. Compact code for complex operations. Verilog allows for complex behavioral to be expressed in fewer lines of code compared to other HDLs like VHDL. For example, operations that would require multiple lines in VHDL can often be condensed into a single line in Verilog. Strengths of VHDL: object oriented programming and dynamic simulation. Object oriented programming. VHDL's object oriented features allow for code reuse and modularity, which can be beneficial for large projects. Dynamic simulation. VHDL supports dynamic simulation, allowing for more flexibility in testing and debugging digital systems. Weaknesses of Verilog. Weak typing. Data type errors. Verilog's weak typing can lead to unexpected data type errors, which can be difficult to debug. Code maintainability. The lack of strict typing can make it more challenging to maintain large Verilog code bases. Weaknesses of VHDL: verbosity. Complex syntax. VHDL's more structured syntax can be verbose, which can make it more difficult to read and write code. Development time. The verbosity of VHDL code can lead to longer development times, especially for large projects. Application domains and ecosystem considerations. ASIC design. Verilog is commonly used in ASIC design due to its concise syntax and support for complex logic. FPGA design. Both Verilog and VHDL were widely used in FPGA design, with Verilog being slightly more prevalent. Software tools. Verilog has a slightly larger and more mature ecosystem of software tools, including simulators and synthesizers. Conclusion: choosing the right HDL for digital design project. Project requirements: design complexity. For large, complex projects, VHDL's object oriented features strong typing can be beneficial. Development team. Consider the expertise of your development team and their familiarity with each language. Ecosystem support. Evaluate the availability of software tools and libraries for each language. Final decision: choose the HDL that best aligns with your project requirements and development environment. Thank you for listening